Alright, so here we have our defined cam part with added face milling, profile, and pocket operations from the previous Jumpstart videos. For the last operation, let's define the drilling of the holes through the cam part. From the SolidCAM Manager, right-click Operations, Add Milling Operation, and select Drilling. The Drilling Operation dialog box is displayed. Of course, since the 4 holes are through holes, and they'll also be defined by only one depth, we'll use the default 2D drill technology. Again, you'll see that the workflow in setting up a drilling operation is very similar to our previous operations. We'll start off by defining the geometry. Click the New button. Now, when defining the machining geometry in a drilling operation, SolidCAM can automatically pick up the centers of all circle entities on a selected face. In the Select Centers By area of the Drill Geometry Selection dialog box, we can use the default multi-positions and simply just pick on the top face of our target model in the SolidWorks graphics area. We can see that SolidCAM has found all 4 holes. Also, if you scroll to the bottom of the dialog box, you can see the 4 selected holes along with their respective X and Y coordinates. We can now accept our geometry selection by clicking OK. Next, we have to define a new tool that's suitable for drilling. To start the tool definition, first switch to the tool page and then click the Select button. Click the Add Milling Tool button next, and then choose Drill from the Drilling Tools list. The diameter of our holes is 5 millimeters, so we only need to change the diameter field to 5 for this example. Now, what if we wanted to add a tool holder? Well, we can easily do that by first switching to the Holder tab. SolidCAM gives us several options to choose from. By selecting Shape or STL, we can define the holder either by specifying its geometry or by an STL file. With the Shape option selected, there are a series of different holders already available to us under the Global tab. Let's grab the first choice in the list, HSK A63ER 16x80. Now if you click the Shape Edit button, the Tool Holders dialog box appears and shows us a 3D model of the tool holder component, like we can also see here. If necessary, you can also edit the selected holder by switching to the Edit tab. For this example, however, we're just going to use the given holder, so go ahead and click the Cancel button. Now if the Tool Picture window isn't activated, click the Show Tool button. This window displays our defined tool with selected holder. If you click, hold, and drag your mouse over the display, you'll notice that you can view the tool and tool holder in 3D. Any changes we make to the tool are updated visually in real time and can be viewed on the fly. So, for example, we can see that our tool is extending out of the holder quite a bit. Let's go back to the Topology tab and decrease the outside holder length to 40 millimeters. You'll see that the Tool Picture window has been updated. Now that we're satisfied with our settings, let's click Select to accept our tool definition and exit the Part Tool table. Next on the tree is, of course, the Levels page. Our milling levels will be chosen in the same manner as our previous operations. Let's click the Upper Level button, and then select the top face of our target model in the SolidWorks graphics area, which represents where we want our tool to start the machining. Then, click OK to accept. Next, click Drill Depth and then pick on the bottom face of our model, which represents where our tool will stop the machining. Again, click OK to accept the selection. When drilling, it is important to note these depth type options. If we leave the radio button set on Cutter Tip, the tip of our drill will come down to the 10 millimeter depth. Or if we choose Full Diameter, SolidCAM will deepen our 5 millimeter holes in order to obtain the full diameter through to the 10 millimeter drill depth. For this example, we really want to use full diameter. You can also manually enter a diameter value in the instance that you wanted the drill to terminate at a specified value along the drill cone. Last but not least, let's move down to the Technology page. We're just going to use the default selections. But let's click the Drill Cycle Type button for a moment. This option allows you to select what type of drill cycle you would like to use. SolidCAM supports the CAM drill cycles that are supported by your CNC machine. They can range from threading, pecking, reaming, boring, and tapping. If your CNC machine has no CAM drill cycles of its own, they can be defined using the general pre- and post-processor program, also known as GPP tool. For this example, we'll just use our standard drilling method, G81. We can now click Save and Calculate to add this drilling operation to the CAM tree and calculate the toolpath. Then, let's simulate the wireframe toolpath by clicking the Simulate button. When we click Play, we should see the toolpath feeding down through each of the holes. Now that we know everything looks good with our last operation, let's use the Exit buttons to close the Simulation Control Panel and the Operation dialog box. And that concludes Part 3 of this SolidCAM Jumpstart lesson, where we've added all our machining operations to complete the part programming. Join me for Part 4, where I'd like to show you more of SolidCAM's toolpath simulation options. And another thing we'll take a look at is generating G-code in preparation for machining this CAM part.